Tonight you're going to learn about parallel and perpendicular lines. So let's go back to geometry from 7th grade. And if you're a 7th grader, go back to probably 5th grade geometry. And let's talk about what parallel and perpendicular mean. So parallel means that there's two lines and they're never touching. So two lines that never touch. So you want to write two lines that never intersect or touch. Perpendicular lines intersect, and they don't just intersect, they intersect at a 90-degree angle. So once again, parallel lines are two lines that never touch, and perpendicular are lines that intersect at a 90-degree angle. So go ahead and write parallel. And I'd like you to copy down the graphs that I have here. So you want to point through the origin, and then you want to go up 1 over 1, up 1 over 1. You want to point over here, and you want to go up 1 over 1, up 1 over 1. And do a perpendicular one, and you need the point through positive 3. You're going to go up 2 over 1. And then you need the point through positive 3, and you're going to go down 1 over 2. Okay, you can pause it and copy those. We're going to look at what are the equations of these lines and what do you notice. So let's look at line, we'll call it line A. So line A, the equation of that line is going to be y equals, and we want to find our slope. So we're going up 1 over 1. Our rise is 1, our run is 1. So our slope will be 1. And our y-intercept is 0 in this case. This one's for line A. For line B, you're looking and you see that it hits at, let's see, 1, 2, 3. So you know you have a minus 3 here. And your slope is up 1 over 1, up 1 over 1. So it's 1 over 1. And that is line B. Looking at those parallel lines and the equations, what do you notice that they share in common? So that, yeah, they share y's, but all equations do, and they share x's. They have different y-intercepts, and that's okay. But what they do share in common is that they have the same slope or slant. So same slope, and we can call it a slant too. So that makes sense because if you're leaning at the same degrees, the same angle, you're never going to touch. If one is leaning a little bit flatter, it will eventually touch the other one. So in order for lines to be parallel, they have to have the same slope. Let's look at perpendicular. So let's call this line C and line D. So for line C, we're going to write our equation y equals, and it hits at positive 3 on the y-axis. That's our y-intercept. And then our slope is up 2 over 1. So up 2 over 1 is 2 over 1 or 2. But I'm going to write it like that for a reason. Now we're going to look at a line that hits it perpendicularly. So we'll look at line D. So you go y equals, it hits at the same y-intercept. That doesn't always happen for perpendicular lines, but it did in this case. Let's look at the slope, a little different. Let's go from this point to this point. So I'm going to have to drop down 1, so my rise is negative 1, and I'm going to go over 2. So looking at those two slopes, there is a little pattern going on there. So for perpendicular lines, you're going to have the reciprocal of the slope, so reciprocal means you just flip your fraction. Also, you're going to have the opposite sign. So you're going to say opposite and reciprocal of the slope. So let me review. For parallel lines, you have the same slope. So that m value, that number in front of x, should be the same for parallel lines. For perpendicular lines, the m value should be the reciprocal, which is flipped, fractions flipped, and the opposite sign.